Good morning here. That was what I said before, so I hope you have coffee. I wanted to say, so the next 3 hours will be as interactive as possible. So please try to participate, interact, and ask questions. Next thing, for those who do not know me, I'm Yura. I'm the product owner of EBRAINS, which is a huge metadata framework for graph databases. We are not going to dig into this too deep today. And I'm also the co-lead of the EBRAINS curation team. So we're going to focus on data and knowledge, particularly on sharing data and preparing those data for sharing. And I show you a couple of tools that EBRAINS provides to do this sharing part. I'm going to start with the getting started section. Who does not have an EBRAINS account? Who did not follow the requirements? So anyone in that room in Montreal? Next thing, you're gonna navigate to the collaboratory, which is shown over there. So the small link, and let me know when you are on. Circle the Highball part, and then select the Highball Winterschool, and let me know when you are ending here. So I'm going to continue now. On the collaboratory, there's basically the main page. You see the agenda there, and I pasted in a couple of links, all related around EBRAINS, data sharing, and open minds. This is for your, if you can go always back and check out the links. We're not going to talk about them in particular today. Next thing we're going to do is actually nothing with the COLA, but you're already there, so this should. So sharing data, I don't want to go into this topic extensively because I hope all of you already heard about the FAIR principles. So FAIR stands for, somebody in the room, the F stands for findability, it's there, right? Accessibility, interoperability, and reusability, and these are the very fancy keywords that propagated since the paper got out in 2016. And the other thing is that I discovered just recently a very nice paper, completely of a different scientific field, who discussed this a bit, like what it means to share data and why we should share data. And they made a very nice overview picture. So we're sharing data because we want to improve science, right? We want to make it more trustworthy, show that data actually that produce certain scientific results are there, and that other people can actually reproduce these results. Maybe also some people will discover stuff on your data that you didn't look at because it was not part of your interest. Data can be combined to do more, right? Because each single research group has typically their own topic they're looking at. But if you combine data, you can discover stuff and do stuff with the data that previously cannot be done. You, of course, can increase statistics, right? There are scientific fields and research where data is scarce, and every data group is sharing those data. Then we have a much better pool of doing statistics on them. Then, of course, it also helps using to use the funds that you receive more effectively, because you have a higher impact and you probably also get cited by these data. And then, of course, we want to increase the sustainability of science, and that's also part of it. So that's a bit of the motivation why I think sharing data is very important. Being fair actually does not mean openly and freely sharing data. It just means that you provide the means to get to the data in one or the other way. So that's also something that you need to keep in mind, that fair does not necessarily mean that you share your data openly and freely, but you can still be fair. Now, I'm in favor of open science, so meaning free sharing, but that's not always possible. Some of you may work with sensitive data, for example, from living human subjects or from patients even, and they, of course, need to be protected, so they cannot just really share under no protection. So, yeah, When you want to share data, this is more the tricky part, right? You need to prepare your data that other people can understand them to the full extent, because on the one hand, you want to present your research and your research data in a nice way, right? Organized and so on. But also you want to help people to make use of this data in the most, or in the best, having the best impact. So the next part is a bit interactive, as I said. So we're going to go through different scenarios that I show you, and something is wrong with this, or something could be improved there. And you have 30 seconds to figure out what is weird about this, or what should be improved. And then I would suggest either you raise your hand here, or the people in Montreal, they can probably shout because you're fewer people there. So if you see what's wrong or what you think should be improved, then let us know. And we see how far you get. Just to put this a bit into context, these cases are a bit exaggerated and very simplified. So first scenario, we really have to just find one topic, or I say otherwise. The other thing is, none of the scenarios I'm showing you are invented. As a curator, I'm going through all data sets on a regular basis in EBRAINS, and I discovered all of these issues in many data sets, one or the other. Not to the extent I'm showing that, right? So there are never these obvious. But so for me, it's really real case scenarios. Okay, so how could you improve this if you would see such a repository with these data? One thing is, first guideline, reduce the number of file formats in your data as much as possible, right? As much as possible, because sometimes you intentionally want to have formats available. But that's the first guide you can follow. So how could this be improved? I see that this one is not so obvious, so I'm going to go there. Avoid proprietary file formats. So lib as well as PLX are both proprietary file formats. I'm actually not sure if they're even closed or open. So some of the proprietary file formats you can still open with open source tools. A lot of proprietary formats are actually closed and only can be viewed if you have the proper licenses by the vendor. So if you want to share files or share data, of course, you should avoid that at all costs. But sometimes it's a bit tricky and not possible, but keep that in mind. So as I said, these are guidelines, right? Not rules. So next one, how could that be improved? And again, these are two examples. They are not, should not be compared, but two examples of a similar issue. Yeah, so unified vocabulary, irregular structure. And then we have the third one here, sorry. Third one missing is, can anybody tell me in the cohort 1 what the numbers mean? So the header is missing, right? And besides the header, even if I know if it's age, the unit missing is also missing. That might be years, it might be months, it might be days, right? I have no idea. So these three aspects you should be aware if you create your data in sheets, right? In overview sheets, or have Excel sheets or CSV sheets and so on. These are things you should be aware of. Especially in Excel sheets, and that's why I put Excel, the lower one is often presented like mixing table structures within one spreadsheet. Not good, because reading those automatically is a pain. So that's why you should always provide headers. You should always provide units for your numbers. And you should always stick to a consistent nomenclature and structure. So next one. How can that be improved? So we are now again at a structure consistency issue, but now within the repository. So keep a consistent organization of files within your, all the stuff I'm showing, maybe I should have made of the note. These are just one examples of how you can solve this. There is not one solution, right? You can be consistent in many different ways, and how you want to structure is a subjective view. This has the big advantage that people that use bits all follow the same rules, right? So, and bits become a bit later, so the brain imaging data structure, which is the standard. But that doesn't mean that it fits your need. right? So maybe you want to locally, at least for you, structure stuff differently, but you can still be consistent in it, right? So you shouldn't switch subfolder structures within your repository. If I now switch the subject 2 to the one of the subject 1 would have been also fine, right? At least be consistent. That's the first step. Yeah, the bit start we are coming to this one. So how can this be improved? So try to avoid unnecessary file hierarchies, right? So as a golden rule for my side, and this is where also, for example, bits collides a bit with that one, is folder that just contain another folder or just contain exactly one file are probably not really necessary and a bit waste of hierarchy. So golden rule here is keep your repositories as flat as possible and as deep as needed, right? Sometimes you want to highlight certain structures, so go ahead and do that, but keep in mind empty folders are typically not a good way of structuring. So how can that be improved? So we are back at consistency, but now in the nomenclature of the folder and file names. So be consistent there, right? Don't switch around and be aware that you make errors, right? So it might even be that you sometimes just miss a dash or miss an underscore. Always double check, because automatic systems, they need that, right? And they need that error-free. So as soon as there is a twist in it, they will not be able to read it with one routine, and they have to make like an if condition, and we don't want to have that. So try to be consistent in your nomenclature. Then there is another one. How could that be improved? So use the sortable nomenclature, right? So use the leading zeros in case of you have digits that are sequential to each other. There are other examples in sense of if you want to sort your files, keep in mind what you want to sort, right? So independent of the leading digits, you need to decide is, for example, if I have a file name that also states a task, right? Compared to a T1 or to a bold file. Is the task the thing I want to sort the files through, or is it the mode of the recording that I want to sort it through, or is it the subject, right? So depending on what should be sorted first, you should order your file names. That's very specific, but just do it consistently again and not switch it around across the repository. So how can that be improved? So provide machine readable metadata, right? That means if you have a repository, just delivering the data is typically not enough. And a lot of data has some metadata in it, right? So depending on the file format you're using, oh, sorry, I already said it. That was the thing. But you need to provide help in order to, for example, give an overview of all the subjects that were used. You also want to have the specifications for here, in that case, the T1 weighted images and the T2 weighted images. There is a nice thing here, which maybe some of you recognize, is that there is an inheritance rule here. So seeing that we only have one T1 weighted spec and one T2 weighted spec, that means all the T1 and all the T2 data are actually recorded with the same specification, the same parameter across the subjects. If that is not true, right, these metadata should lie directly next to the data. So if it's depending on each subject, how the parameters change, then they could be located directly next to the data that they're accompanying. There are other ways of providing such metadata, but you should always keep in mind that you accompany your data with metadata that help navigate and understand your data a bit better. What does machine readable mean in that case? Machine readable metadata are typically organized in key value pairs or key value unit pairs, or also there are multiple properties you can attach to it. But so you have, for example, we had it before in the Excel sheet, right? So we have age as the key, and then we have values of the different subjects. And then we have the unit for the age, which we define as year. This can be either sorted in table structures, like we saw before in the Excel sheet. We can also do this in actually key value formats like JSON that you can see here for the different specs. There are more metadata formats that specifically work with these key value pairs, but just keep that a bit in mind. And the other thing is potentially, right, if I have something like a fuzzy thing like noise or quality of the recording, right? It's probably something I want to also tag, but then I should use the same tags again, right? So I should not write in one case, the recording was noisy, and in the other one, noisy, and in the next one, I'm writing a bit noisy. So you should make an idea of what you want to say, like maybe set a scale of different noisiness level, and then stick to this exact scale. These can either be one string words or maybe even more descriptive, and then you just assign numbers to it and then assign your data with that one. Okay, so let's move to the next one. So what's wrong with that one, or what could be improved with this one? So what we're gonna emphasize here is stick to community standards. I picked one here, right? So you don't have to do that one. But Excel, for example, avoiding Excel is one of the things. So Excel is a community standard for some communities, so to speak. But you should avoid that in a scientific context when possible. And BITS has multiple standardization parts within their repositories. On the one hand, they have a very strict rule in how you should organize your repository. They also have rules on how you should do your file naming. And they have rules that you have to create certain metadata or so-called sidecar files in their case. This is one standard, and it's true, like it's used for a lot of human imaging people that are exchanging human imaging data, but they have several extensions now also for EEG and SEEG, and I think MEG, I'm not sure if that one is out. So there are a couple of modalities that they are support, and this is really expanding because it's a very active community. There are other standards, so if you want to learn a bit about standards, get in touch with me. We are not going to dig into that today. If people know bits quite well, they realize that something was missing. So how could that be improved if we look at this one? Okay, I'm going to resolve this now because we have a limited time to deal with this. So README and a data description. That's typical for bits as well, because you should always provide a human readable data descriptor with your data. That can be super extensive and actually published in a journal like Scientific Data, but it can also be a simple small README with a summary of stuff that you decided for the data set. For example, following a certain standard, or for example, why certain reportings are missing from certain subjects. Things that you decide along, things that you want to make people aware of, right? So please use the data in this context, but avoid using it in another context because maybe our quality didn't emphasize that you want to use it that way. So things that you want to explain to people about how your data should be used and how your data was, for example, created, certain decisions you made in that creation, you should put in a data descriptor. And they can be super long and they can be relatively short. That also means a data descriptor should focus purely on the data, right? So that goes also for the abstract. I don't want to, if I want to use data, I don't want to know what research you did with those data. That's like the one sentence that is nice for me to have in the sense of what your intention was working with these data. What I want to know is how many subjects did you use? What modality did you use? What are the formats that you used? How much data do you have? What's the file size or the size in general? Things like this, that's the data descriptor. All the research you publish in your research papers, or you give as a hint in the sense of, well, as a usage example, we have that paper published with these results, or here a small usage example of how we can use those data. But the rest should really focus on the data. So writing a data descriptor also means, in principle, it's relatively straightforward because you just go along the facts of your repository. Okay, How can that be improved? That's the last one, I promise. You mean switching the order of the result? That's a design decision. I intentionally turned it around now because I just wanted to make a point that that's also okay. Ambiguous naming is okay if it's distributed along a repository. So meaning it can be preferred design-wise to name them exactly the same in the different repositories because it's easier for a machine to read those, right? Because if I'm in raw or derived, that's the only thing I have to change. If I want to look at cell 1, I just not need to know one name. That's a design decision. If you flatten that structure now, right, and just put, then you're screwed, as you said, because they have the same name. So this is a bit of a design decision, pro and cons. You have to wait for yourself. I prefer names to be a bit more specific, typically. But it would be still okay, so I wouldn't complain about this when I receive it as a curator. What I would complain about is there is raw and derived. What does that mean? Exactly, so I have no information on what was done with the data. So in case of your data, please always provide used code. Definitely, if you used code, provide the used code either in your repository or make it clear in the data descriptor, for example, we actually find that code, right? Maybe it's published in a tool set already on GitHub, for example. The other thing is you should also always provide, even if you didn't use code, right, to process your data, you should always provide advice on how to load, read your data, analyze them. So if there are tools that you know that are good to load your data, or if you have code available to read your data, then provide this somewhere, or at least provide the people that should use your data later on with that information. Okay, so that's about generic preparing data and metadata for data sharing, right? So, and actually it's not only helpful if you want to share your data with yourself, you also share your data, right? Remember maybe your project a year ago and you want to go back and do some different analysis. So keeping these kind of rules and also helps your own routines and your lab colleagues, for example, to work with your data also easily. So it's sharing on a very different level. It's not only by publishing your data somewhere publicly. Okay, then we move to the next one. So upload data and metadata. And now we are gonna, all of you that have a laptop, now we have to go to your laptop and we're gonna go to the Colab. So on the Colab, you have here on the side 4 different fields that I always refer to on the slides. And what we're going to do now is we're going to go to the bucket and open that one. Okay, everybody there? Okay, what I want you to do is now, very stupid thing. Take any small file from your laptop and just upload that. It's best in this folder, right? So I already uploaded one file for myself. Just take a small one and be aware that you should upload something that can easily be shared across these people here and the people in Montreal. And Montreal, again, just upload something. One small one. Yeah, there's stuff, even folders. Good, so that's we now officially uploaded data using the data proxy UI. That's one of the tool sets that EBRAINS now provides for uploading data. Your data is now located on some storage in Switzerland. And the data proxy basically navigates the whole, who has access to this, who can read, who can write, and so on. Your read and write access, as some of you noticed, are tightly connected to the Colab, right? So if you don't have access to the Colab as an editor, you are not going to be able to write in here. All of you, and that's why we ask for your EBRAINS account names in advance, are connected to this Colab as editors. And that's also the typical way on how you provide data now for EBRAINS when you are going through the whole curation process. The curator will create a Colab for you, adds you as an editor, and then links you to the data proxy link, right? This is typically then only the data proxy that you see here on the small side. And then you can upload your data there interactively by just drag and drop. The other way of doing this, of course, is programmatically, and that's what we're going to do next. So all of you, back to the collab, and now we're going to go to the lab. So you can open, just click on this one, and I will do this again as well, just to show you. Typically, what you then see is here, select lab execution site, because we have multiple centers providing compute power. It doesn't, it's really, you can select whatever you like. Either select the Swiss one or select the one in Europe. So I'm just gonna go with the.
Yes, yesterday Timo recommended to split that randomly to share the load.
That's okay. We are not doing it, so Timo does do more stuff than I. Should be fine. Not very big things we're gonna do. So if that opens, then please go to the upload Jupyter notebook. So that's, and this is now slow, but you see upload underscore data, open that one. You should see this one, basically. Everybody there? So, a bit of this I told you already before, so you are able to do this now as well because you're here an editor of this collab and can execute things. The thing to work with EBRAINS, right? With EBRAINS collab, EBRAINS buckets, also the knowledge graph, which we will do later. You always have to authenticate yourself, and that's with your EBRAINS account, right? And there is one way of doing this. You probably did it yesterday as well when you worked with the Zebra Explorer. You also had to authenticate yourself. Today we will just use the CDLO gap token part, which perfectly works well within a collab because here your account is immediately connected, and it will just take your token from your account. If you want to work locally, then you have to get your thing elsewhere, right? So your token elsewhere. I will show you where you can get your token in a minute when we have a look at the metadata. But for now, I suggest we stick to the notebook and just run the upload things here. Normally, of course, you would upload data from your local machine and not from a notebook. Okay. So for test purposes, I uploaded some data, invented data to the drive, and this is the one we're going to upload now from the drive into our bucket. And this is a small code snippet, so all of you know how to execute cells in the Jupyter, right? So you can't just execute this. The point is we define our bucket, so that's the bucket name. It's a very long one. Normally you get a really long number from the collab team, for example, to upload things. And then you need to know that all the buckets have the same, you see here, the same prefix. So we're going to build this complete name. And then our source part is a test subject CSV that I uploaded in the drive. So there's no path needed because it's directly in the same path as the Jupyter notebook. And in order to distinguish who is now uploading what, because otherwise the thing will complain and say this file already exists, we add a little prefix in front of the name of that file when we upload it. And this whole thing works with HTTP, meaning that we have in the API, we first need to get our upload URL. And with the upload URL, we can then actually upload the data. And this is what we're doing here. So here we get the upload URL. This is where also your token goes, instead of verifying that you're allowed to do this process. And then you can later on use the upload URL in order to upload the source file. So let's just execute this, everyone. And you see it's asking me for entering my prefix. So I'm just entering my name here and press enter. And then it should tell you response 201. Does this work for all of you? Perfect. So 200 and HTTP always means, yeah, this worked. Something worked. If you need to look up the HTTP status code things, I put in the link to the documentation. But 200 is always good. 400 means, like 400 something means that you did something wrong. 500 means the system failed. So that's the rough summary of those. Okay, so let's check what we actually did, right? So what did we upload? So I'm gonna switch back to the bucket here and make a refresh just to be sure. Okay, and you see here we have a. I'm gonna make this a bit bigger because I think it's a bit small. And we have here an upload data item. That's where you uploaded data. And you see, oh, nice. So it worked at least with a couple of people. So that's the very small code you need in order to upload your data. Of course, if you have a whole bunch of files, you should need a routine that runs over this, right? And upload the whole thing. All right. So everybody good? Also not here? Okay, since nobody is shouting anything, I'm just gonna continue. So that's what we did now, right? So we uploaded things in data. Now let's switch to metadata because we just uploaded data now, but we want to register metadata within a graph database system. And in EBRAINS, it's the EBRAINS launch graph. That's that graph database. So please, everybody, navigate to that URL. And you probably ask again to be logged in again with your EBRAINS account. So just do that. So everybody is seeing this. Of course, not exactly this because that's me. That's my login. But does it look like this and reads you as well? Okay, so it's not only friendly to me. Okay. So this is the knowledge graph editor. So this is the tool where really all the curators are working with extensively if they are working with your data, if you want to share data through EBRAINS. We're currently testing with a couple of people if researchers can actually upload their metadata themselves using the editor. And these are also connected to the Colab. So again, if you're an editor or an admin of the Colab, the curation team has the power to assign to you a knowledge graph space. And you see up here, there is a, I'm gonna do this bigger again. Up here, there is a thing that you can expand as well, right? In your case, it shouldn't show you that huge list. So in your case, there's probably that one, right? And then there's another one called MySpace. Do you see anything else?
Control.
Ah, yeah, the control is fine. That's also something. Okay, but so you only see spaces within the knowledge graph that you're allowed to access. And these can either be addressed with read access and write access, or only read access. So the control, for example, should be only read access. But the other two, the Colab type or Winterschool, because you're an editor of the Colab, means that the associated Colab space is also for you open for read and write. The same goes for MySpace. The MySpace, as the name says, is your personal space within the knowledge graph that you can use in order to play around. This is not necessarily connected with OpenMinds, which is the metadata tool that we use in the background, the metadata architecture that is used in the background if you want to publish data through EBRAINS. And what I did for your space, if we now go to the search button here on the top in the menu, you see that I entered on the side 2 types, and these types are OpenMinds templates now. These are OpenMinds conform templates. And we have one for person and one for ORCID. All of you have an org ID? ORCID? Cool. Then we can test this. If not, don't worry, you don't have to enter anything. It's a nice thing though. You should register an ORCID because it makes you unique as a researcher in all your publications. So even if you get married and change your name, people will find you. If you have a name a double name, for example, like two initials, then people might cite you differently in different publications, but the orchid, that's the unique one, right? So this is persistent, a unique identifier for you as a researcher. So for those ones who don't have it, please register. It's a good thing. What we're going to do now, we're going to create a person instance within our knowledge graph space. And all of you can do this now in parallel to me. So I'm just opening the person part, and you don't have to fill out all the stuff. I should probably fill it out rightly. So I'm just going to put in my name, and I actually will save this just to show we can save it. Now we have me as a person in there, and I always forget my orchid. But I will quickly, you see, I already searched for it yesterday. So, best is we just take the one from the address bar, because that's the actual official accurate way to deliver orchids with the HTTPS and font and so on. And now we go back to our editor. And I'm just going to add this one as also. This is the digital identifier, and I'm just going to say add a new orchid. And then it opens another thing. So obviously it's not the same template used now. And we saw beforehand that we also had two templates there. And this is the one for orchid. I paste in my orchid and then save it. So if I go back to search and make a refresh, and then go. So ignore the subject and subject state. That's from another notebook we're going to look at. But we already entered a couple of persons, so this is nice. Here's me. And what we also can see is that potentially we have at least my orchid registered already. And that is linked to me as a person. And you can see this also if we go to your person and then go to this little explore thing. This will show you the entity in the graph mode. So, right, we have two templates, meaning we have two nodes. And these nodes are now connected with each other. So we have me as a person and the orchid, which is connected to my name. And this is how graph databases work, right? So we have nodes that cover certain aspects, and then they are connected through the graph. That has the advantage if now somebody wants to reference me, they don't have to reference me through person. They can reference me directly through my orchid, which is much more reliable than me as a person. Basically, it's a bit sad story now, but yeah, we are numbers. We should be numbers. Okay, so you can play around here in this editor if you want to. Also later on, or in the next couple of days, so we won't remove you from this one. Now, subjects and subject states appear here. So I didn't add them intentionally because I wanted to focus on certain things. And we are now going to do the subject part, but we're going to do this programmatically. So you now have again interactively how to upload data, metadata, and now we do this with code again, and we're going to go to the metadata upload test in the lab. So we just want to open that notebook. Let me know again when you're there, when you're at the lab. Okay, so first thing we of course need to do, and you also would need to do this locally when you're working with this locally, is you have to install the EBRAINS knowledge graph for Python SDK, which just pip install, so this is easy to do. And then you can work with the KG core Python package. And this is how you upload data programmatically within your knowledge graph spaces. So there's again a summary of what you can do or cannot do, depending on your account. So now the KG core Python actually has a nice way of dealing with authentications. On the one hand, I talked to you about this one for the notebook. This can be replaced if you work locally with your EBRAINS token, and you can get this actually when you go to your editor space, and then up in the right corner there is your profile part, and it says you copy your token to the board, right? So this will give you the string of this last token part. And if you want to work locally, you really just have to replace this function here, the CBLO function, with that token as a string, and then everything is built up. This is one way of doing it. For example, for the data proxy, you have to do it that way. For the KG core Python module, they actually can also do this via this function. If you use it that way, so the whole 2 lines you replace with that one, then it will ask you, it's an interactive thing, so you press your code and it will ask you to go to the website to confirm your authentication, and then you can go back to your code and it will just run. So that's another way of authenticating when you're working locally on your machine. There are other ways, and I put in the link so you can explore this a bit. For the people that know Python well, shouldn't be really an issue. So we're going to execute this now to just install the whole thing. In the background, which takes always a couple of seconds. And then we're gonna do the following first. So we're gonna authenticate ourselves, and we load the test subject CSV that I put into our drive. And I'm just gonna execute this again. And you see here, I'm just printing this now as a dictionary, right? So we have subject IDs, several of them. We have the age, we have the age unit. We have a biological sex, we have a species assigned to this, and then we have a session, and the session is actually 2 things, awake and asleep, meaning obviously something was done in 2 different time points for that subject, right? So we have 2 states that we want to register for that subject. And then next thing, but I already talked about this a bit, so the EBRAINS knowledge graph, if you want to publish your data there, you have to deliver the metadata open MINDS compliant. And this whole structure that you see in the editor, right, the template, that actually is saved in the background as a JSON LD. So a JSON LD is really just a JSON with certain special properties that you always need to provide. And I just show you here now templates on how to do this open MINDS conform and have JSON LD in the background. So JSON LD always receives an at type. This at type always refers to the actual metadata schema it should be evaluated against, right? So we have a template, so we need to validate our whatever we do with that template, and this template is exactly this. Oh, yeah. Okay. While I'm showing this, I'm going to override whoever is working on this right now. Sorry. The other thing is we have an at context, and this defines the at vocabulary. And in our case, we use always the open MINDS vocabulary, which is also the same. So all JSON LDs always have these upper parts. This is true for all of them. The only thing changing is, of course, depending on what you want to enter, the schema type differs. So here we have the subject schema type. Below, we have a template for the subject state. And then we have different properties that are true for this schema type. And to show you a bit where you can find this, I pasted in the link above as well. As we have here the HTML documentation of Open MINDS, we're working on the version 3 branch. And what you do is you just search for your schema. In that case, we are using the subject, right? And then you see here, okay, that's the type of that schema. So all the JSON LDs should get that type. You see down here is the vocab that says how the properties should be complemented with. And then you see here in bold letters the actual properties that are required. So you always have to or should always provide them. So in that case, it's species and studied state. And then we have optional ones like the biological sex, the internal identifier. We can group those and we can provide the lookup label. So the is part of we neglect for today. The internal identifier we have in our CV, right? So in our CSV, we have the sub -01, for example. The lookup label is for the purpose that we want to define probably something which is more use specific, because the knowledge graph now, if we upload all the subjects now at the same time, subject 1 will be a bit ambiguous, right? So in order to find your subject more easily, you can provide it with a lookup label that's specific for you. And then we see the following here. So we have biological sex. And biological sex is actually something that links to another object, so meaning to another schema. And the control space, you see, holds all the control schemas and the instances of these control schemas that we define in OpenRAINS. So if we click now on biological sex, this is a control term. All terms have the same set of properties. All of them require a name, and then everything else is kind of an add-on we develop over time within OpenRAINS. And then we provide certain controlled instances. For example, you can select from female, male, hermaphrodite, and not detected for the biological sex. So this is how linked data works, right? So we're linking objects, and you saw this before between person and ORCID as well. So if we go now to our study state, this is why we have a second schema template defined in our code in the notebook. This is the state, and the state basically holds everything that is only temporarily true for one subject, right? So imagine a longitudinal study where you study the same subject but in different timeframes, like maybe every year. You want to enter these different states because the data are connected to that specific input, not to the subject, right? The subject biological sex shouldn't change typically, not in humans at least. There are other species that can do that, but not in our case. The species, right, shouldn't change between the subject, within one subject. But the age category, right, if it's an adult, a juvenile, an infant, or the age concretely, right, the concrete age. As well as the attribute, and this is what we are gonna do next. Like we had asleep and awake, right? So there were two states in which the subject was obviously measured or imaged. We don't know, doesn't matter for our case now. But we want to split that and say, okay, we have two states. One was awake, one was asleep, and that's where we put the attribute. And again, here you can just go to the subject attributes, and you see the list of control terms that we already provided in EBRAINS, or actually here in OpenRAINS. If something is missing in case for your own data later on, feel always free to get in touch with us and just say, I need that term and this is missing. Can you please add this? We're gonna evaluate this, write it in if it's a nice suggestion, provide a definition. In the next case, we can even make linkages to external resources so that you can make use of this. This is really a community effort. So depending on your input, these lists will increase. Okay, so now we go back to our code. So explaining a bit how I make these templates, right? So I looked it myself up. I actually wrote this hard-coded in here. I know this is a bit quick now for people that are not super familiar with how to do this. Feel free to always get in touch later if you need more explanation. So this one we're gonna run now, this cell. And this is just defining another parameter set. So it defines the templates and it defines already the attributes that I've already extracted from OpenRAINS. So I say the sleep actually has the ID within the knowledge graph that follows this ID code. And the same goes for female and male. And you see that here, this is actually something which is human readable, which is something we provide from OpenRAINS. There's always a second ID attached from the knowledge graph, so from the EBRAINS knowledge graph, which is really UUID, meaning a very long number, which is very globally persistent and globally. Okay, somehow I set that up wrongly because we should be able to work on that in parallel. So next one, we now create those, and what we do is for the lookup table, we do a prefix, right, so that we can make something specific to you. And we use just again the name, and we are now uploading this to the knowledge graph space of this collab. So again, we have the name for that one, and then we now just go through the subject list, catch the subject ID. We go to the different states that are stated in the session, and then assign the attribute and the age value to this one. And we also set the lookup label for the subject state, which I now really just define with whatever you entered as a prefix, the subject internal identifier, and then I just say subject state, so awake or asleep. And then I'm going to upload that state, and I'm going to retrieve the UUID the system now assigns to that instance that you uploaded, because that one I use then to create the subject and link the state to the subject it belongs to. And if we execute this now, we have to deliver our prefix again. I did a weird one now by accident. Now it goes through the whole list. So we have 10 subjects in here. And it just provides me with some feedback of I did that successfully, so which is nice. And if we now go back to our editor and to the subject list here, we should see very many, like a lot of subjects now actually. When all of you do that successfully. So right now it's only 63. So imagine all of you are doing 10 subjects, that means that there should be much more, I think, in here. I'm gonna upload again. Coming. Okay. So just to show you again, so we're now going to check. If we open that one again, so within the editor now, we created these subjects programmatically, right? And we uploaded them, and you see that they got whatever you put in here as a prefix, the underscore with the internal identifier. The internal identifier is that we connected it to the entry of Open Minds, which is Homo sapiens for that one. And you see also why we're doing this, right? So Open Minds has control terms, and you see below why this is so important. This control term now is a node in the knowledge graph system, and in the whole knowledge graph system, we have over 3,500 subjects now connected to Homo sapiens. So this is the point, this is the major advantage of a graph database, instead of just typing in as a string Homo sapiens, right? So then you're really, if you just have a full text thing, for example, it's much more difficult for a system to detect, is this really the same, right? Because you could have made an error, maybe you didn't write it Homo sapiens, maybe you forget the last letter, or you wrote it non-capitalized and capitalized, or you didn't write Homo sapiens, you actually wrote human, right? So all these different things with free text, they are nice, they are super flexible, but they are much harder to deal with on a reliable search query level. And these tags or control terms, they are actually nodes within the knowledge graph that can be really uniquely assigned to any other object. And this is then you see here, you're now really connected to the knowledge graph by creating these subjects. And then the same goes for your states. Of course, we are not connecting this to data now, but these states in principle can be directly connected to single files or file bundles, meaning you can actually assign all the files that are true, that were generated or belong to that subject, is something that you can also connect in the knowledge graph. So we're not doing this today because that's way over the exercise now. But if you want to learn more about this, we always free to get in touch, and especially if you want to learn more about the Open Mind structure, which is really complex, right? So we are not only doing basic research and basic metadata, we're going really in-depth. This means that Open Minds itself is quite big. The essential parts for publishing are though overseeable. So if you want to learn how to use all of them, I'm happy to set up something where we can meet or have a private session on this one. Okay. I know that the documentation, for example, so written documentation is still scarce. This is a matter of time. We're working on this and promise that we will hopefully deliver nice documentations as well. Okay, so then let me see where we are. But that's it for now. Okay, so we are back. We are now at the second part of the workshop. And that we will start with searching data and metadata, and we again start with an interactive part. So please go to the search.kg.ebrains.eu page. This should look like this. when you reach it. So if you share data, they will show up in a search engine, right? That's the most obvious or visual thing in EBRAINS in the knowledge graph is the search engine. But it's considering if I'm talking about the knowledge graph, a lot of people actually are referring to the search engine only. If I'm talking about the knowledge graph and not specifically mention that we're talking about the search engine, I mean a whole data management system. The search is one part of it. You already learned another one today, that's editor, right? That's also part of the knowledge graph management system. As part of the editor, there is a whole publication release mechanism running in the background that registers new data within data science and the UI. That's another part that the knowledge graph is managing. And then we have a couple of other tools connected to this. The graph database. So where the instances are stored, the metadata, the linkage to the data and so on. That's the core part of it. That's the database. Okay, and the search now gives us access to at least some of the instance metadata that you registered and puts them into a nice looking landing page. So first thing, I need to have a little cheat sheet now, what I'm going to do with you. So first thing is we're going to explore just a bit. So you can each do that for yourself. You can see here we have a search field, right, where we can enter some free text. You see here that there is also this icon, so you can also log into the knowledge graph. That has little meaning in your case, except if you are actually publishing data. If you are then added as a reviewer to your data sets, you can also see your unpublished version of the things if you're logged in. If I'm logging in, then we will see all the data in the EBRAINS knowledge graph that are not yet published because I'm a curator and I have basically access to everything. So I'm not going to log in because I don't want to spoil it. But yeah, then we have here on the left side a couple of things, and this is called categories. Categories means that there are actual landing pages for these different categories. We see we have projects, we have data sets. And data sets mean, in our case, they could be experimental or simulated. Then we have computational models. We have metadata models, and there are a couple of them in already. Metadata models means something like open minds, or in that case, the ones that are registered here are common data elements for clinics. So where metadata structures are defined for defining certain contexts in the clinical part here. For example, traumatic brain injury. Then we have software tools registered in EBRAINS, which is helpful because we can connect the software tools to specific data formats, which we define as content types. So these are software specific formats. And we assign, for example, all the data we get in, we try to assign to these content types, which are then connected to as either input or output formats to the software tool. That's a work in progress, also don't take the input at the moment too seriously. That's really a huge curation effort. And then we have contributors, and contributors are persons that are either custodians or authors or developers registered within the knowledge graph. This category section will grow in the near future and will also brain atlases and common coordinate spaces, as well as web services and workflow recipes, meaning workflows as analytical pipelines that are available for you to execute. And there are also going to be live papers there. So these are small interactive papers where you can enter code and data and models in order to be interactively run in a company, like as a supplement to, for example, a research publication. That's something Andrew Davison is developing. They're already online, but they're not yet integrated in the knowledge graph. So this is something we're doing at the moment. So this section will grow, but that's like for you to navigate. If we go to data sets, again, I want to show you another thing, which are the filters. So these are faceted filters, meaning these are really working on control terms only. So only if a data set or a model or something is attached with that control term, it will show up here as a number. You see these numbers beside, these always give you the count of the current instances we have. So for data sets, we currently have over 900 data sets inside. For models, roughly 150 and so on. If we now test this a bit, and we're going to go to the search and, for example, just say microscopy. Did I write it correctly? I think so. So, and you enter this. What did we see now? What changed in the layout? Yes, less category. So it's automatically adapting to the search text. And what it also does, and you see this, is highlighting where it found it. And you see also that it counts it in full text, right? So free text. So this field up here is a free text, full text search, right? What you also can see is if I say, I'm not sure if this works now. It didn't do the suggestions that I wanted it to do, but what it does is that in case you have a typo and you can't find that exact word, it will make you suggestion in order, like alternatives for this one. I actually wanted to see if it finds animals, but with names it's always a bit tricky to do these things. So we ended now microscopy about here, but now we want to use microscopy now as a free text search. We just want to filter it according to that one. So we can also just click on here, and then you see that it changed even differently. So right now we only see data sets in the categories, and that's the reason because none of the other objects within the knowledge graph actually uses the microscopy control term as a tag. Only data sets do this. And also the search field here changed a bit, right? So we don't see the ones that have it in the full text. We only see now the data sets that actually use this tag to annotate the data. And if we open one of them, I see we reach one of the unit frame, which is already good. We see that under experimental approach, the term microscopy is actually attached. And if we click on microscopy, then we also see it's actually connected, right? It's a control term instance coming from OpenMinds. And this has an ontology identifier, for example. It has an external definition, which is here in the Intellex project, which is an ontology integration database. And we have a small definition. You will not see this for all of the control terms. You see here, every time you can click on it, there's at least something additionally defined for that term. If we only have a name and not a nice definition yet or any other linkage, it's currently gray. So this is a continuous effort. If you see something like this and you think that you can provide a nice definition, please get in touch and we're going to integrate it and then expand this a bit more. And also, of course, if you're starting a registration process, and you are not finding the term that you want to have on your data set, then let us know. Keywords at the moment, again, are free text. We're going to change this also to control terms in the near future, but that's for later. So this is now a bit the difference between the free text search for microscopy versus the text search microscopy. So the filters themselves, right? They are actually quite nice because you can, of course, also combine them already now in the search. So what you can do now is you can, for example, we select neuroimaging. And then we say, the species, yeah, we can combine it with species. We could combine it with data accessibility. But what I actually want to do is I want to figure out which of the data sets working with neuroimaging use NIfty-1 as a format. And then I can have, I have two filters selected, and then I get only the data sets that provide data that are formatted in NIfty-1, or let us know as a curation team that actually what they used was NIfty-1, because that's one of the metadata that is typically not missing. So we sometimes get NIfty files where we then ourselves have to figure out if it's NIfty-1 or NIfty-2, because there are actually two versions of that format. So you see, metadata annotation is quite important to get to the results that you want to have in the end, but it's also nice because you can combine it then with all the other data sets that use the same thing. So feel free to play around with these combinatorics of the filters. Then what we're going to do again is I'm going to go back to the previous one. Right, so we have microscopy selected. So if we go now to microscopy again, you can take any. So feel free to do something else. I just use this as an example. The other thing you see here is that we have actually version data sets. That means that you can come with one data set. For example, versions can mean very different things. In case of the unit brain atlas, it's really a unit brain, so they really more areas, and then they make a new release of the atlas, including more areas, and that's the version here. You see also that we have always below here a version specification, which now tells you what is the difference to the other versions that were previously published. You can also go to the version overview, then you see a version independent abstract. You see version independent authors and custodians, and if you then go to the version overview, you see here a list of all the versions with the version innovations, so meaning the differences between the versions. So you see, we're switching back and forth. That's really the graph, right? So we have different nodes in the background, and what the knowledge graph search is doing in parallel, it sometimes hides nodes from you. So it already makes the consolidation of certain information in order to put it in a nice layer for you to read. The other thing we see here also nicely is that actually the data descriptor, which we encountered before in our preparation part, is actually part here and integrated. You can also define additionally to a normal DOI, which would be just assigned to the data set. If you want to have double citations, for example, combinatoric data plus a data descriptor, or combinatoric data plus a research paper, you can actually request this in EBRAINS. Then this is connected now because we have the metadata representation on all the files and file repositories. We also register that for you in EBRAINS. We have now the direct connection to the data. And I go a bit ahead here because I don't want to go back to this again, because the download part will be the next session, but the interactive thing is working out quite nicely here. So we see here our file structure. Right, and then we see here that there are certain files. I'm not going to download now one of the nifties, but I can click on one of the files here, and then I can say download, and it will just download me that file. Right. The other thing, what I can do is I can just go to the whole folder, and also can say download. I'm not going to do this one because it takes too long. But if I'm now downloading that one, it will download me the whole folder, the whole repository as a zip, right? And then I can archive, unzip archive locally. And you can do this with each single folder within a repository. So you're not forced to download all data all the time. You can really be selective about this. The other thing is then you can attach direct publications that are directly working and connected to that data set in here. And then we, of course, have our specimen, like all our subjects that were used registered. And the unit brain is a nice example because we always have a group of subjects that is like 10 subjects. And these 10 subjects are actually reused in multiple other data sets that are all connected to the unit brain. And you see here that this group is also used by other data publications. And in total, there are these ones potentially, in that case, these are all the different versions of the data set. In other cases, these are actually different data sets, for example, for different areas that were looked at. And we see this for the subjects, for example, we see here subject 1. Then we have the tissue sample brain for that subject, which has a couple of information and additional remarks, and so on. In principle, there could be also tissue sample collections. I think we don't have that registered. No, we have one registered in this one as well. So this for that. Now I'm going to show you another example. I first need to do this. Sorry. So this is another data set which has different features. So the one I just showed you, they don't have the link to the knowledge graph to the atlases yet. This one has, not to the atlases, but to another tool that EBRAINS supports. So we see here that the tissue sample collection of this one is located on the locality viewer of EBRAINS, but the Zebra Explorer has also these links to certain data sets within the system. They're not present all yet. We are working on this so that all of the data sets that are actually already integrated in the Atlas receive all from this viewer link on the side, and this takes too long. Sorry, so I'm going to switch back. But this is something which is going to be added as soon as possible for all data that are integrated in the knowledge graph and visible here. The other thing here is that for the get data, what we are also doing, which is like a continuous creation effort in the background, we're actually grouping files and annotating them with the correct format. So filter by is always referring to the format. So we see here we can filter according to PDF, to the QuickMe format XML, or to the TIFF images. And I can just show you this. So now I changed this repository, and the only thing for subject in here is now the XML files. And now if you download all of this will also filter the download accordingly. Should I use? Now we say none again, and then we also can do different other things. For example, we can group according to tissue sample collections. In that case, it's a bit boring because they anyway group their repository along tissue sample collections. But if we group after protocol, we see that we are now getting different folders here, which actually are only holding the anchored TIFF files to the, in that case, I think it's the L mouse brain atlas they registered these single slides to. And the same goes, for example, for tasks or for other modalities like techniques. So independent of what your file is structured, we can provide you with the annotation to reorder that and order it, for example, according to T1 weighted files in a bit repository so that you don't get the whole subjects, but only the ones with the T1 weighted in. So that as a side thing, why we're doing all this metadata learning is exactly to provide you with these features in the knowledge graph search. And there's one more thing I want to show you for downloading data. This is coming with the point that some of the people here are interested in data protection of human subjects that are coming from the clinics or from other single human subject parts or patients or volunteers. And the human intracranial database is one of these data sets. So these are, sorry, that was not my intention. That is an SEEG data set. So this is really an IEG data set with a huge database. They have now the release 5 actually. I'm working on that one to release that one. The 4 is the one latest. These are increasing subject numbers. So across the releases, they increase the cohort size. Starting with 30 subjects in the beginning, and now we are at 80, and this release 5, which is upcoming, makes the whole thing round, and we are at 100. We register also metadata for those, and you see here that, for example, in the first cohort, they had a couple of information that they can share per subject. And then in the later cohorts, because they were working with different hospitals, the metadata reduced to the essential things that they are allowed to share for the subject. So here it's just adult and that they had epilepsy. And then the other part that you can do when you end up here is if you're going to go to the get data, you will see this sentence. So this says this data requires to explicitly request access with your EBRAINS account. If you don't have one, please register. So if we now say request access, this will, you see the little button above, right? Data proxy, you remember that one. So we are now in the data proxy and say request access. And it tells me now that I have requested access to pseudonymized human data. And we have to remind you now as a user that we have a data usage agreement that defines this, right? So in the sense of that forbids me certain things, I have to be aware of this. And actually what they did is, I'm going to quickly show you this. This will take a while now. No, remind me later. So you see, I have to work through a lot of emails. But this email was not sent to me by my request. And when I get that email, I just have to click on this link. So I first should read through all of this. I'm skipping that now with you. So I now confirmed that I understood my rights and the rights the data have, and now I'm getting access to the data through the data proxy, not the knowledge graph anymore, like not the knowledge graph KG, but really the data proxy, and now I could download the data. We're currently trying to figure out how we can connect this to all the filter functions we provide you with. That's currently not disconnected. But this is how you get access to GDPR sensitive data. Yeah. So that was our little excursus in the search. Now what we're gonna do? Can anybody imagine? We're gonna do something again programmatically, at least half programmatically. So we're gonna go to the query builder. So this is query.kg.ebrains.eu. Can you navigate it there? Okay. So this is how it should look like. All right. So the query builder, as I said before, we are working in a graph database, and graph databases are particularly challenging in creating queries because they have typically their own query language, and this is typically not so easy to define. To make that a bit easier for you to build rather complex queries, the knowledge graph system actually provided this query builder option, which allows you to interactively put your query together and then copy the code somewhere in order to use it. It even provides you with the option to save these queries online, and then you can access them again via these review IDs as a reference. So we will do a very simple query now. I prepared a more complex one, which you all have access to. I will show you this later on. But for now, we're just going to go back to our person schema because we didn't use that in the beginning. So we'll just say, okay, we want to do a query on persons. And we say, okay, select. And then we need to do something. And you can either select a save query, that's a bit boring. We want to do a new query, right? So then you end up here. So the person part, that's your starting point, right? So we're searching person. And then you can say, well, I want to get in my result, I want to have the family name of that person, and I want to have the given name of that person, for example. And then we can do maybe something more. We can, for example, see, let's go to the digital identifier, right? And say we only want to have persons which have an ORCID attached, right? So we say this is required. And we want to see that ORCID, right? So we're going to select the identifier and say that's required, for example. So then we can see that. So this is actually how this query looks like. And it's, you see also that this is actually defined in a JSON format. So it's a query language that is also JSON based. And then we go to the lower part because we just want to interactively run this now. And what we want to also, or can select here, and I can select this, and probably you can select that too, but for you it doesn't really make sense because you don't have access to any in progress data. So this should be released. And the size now, we limit the result size for now to 20 and just hit run it. Did you all run it? Okay. Then you see that in total it says 8, which is a bit weird. There should be more in. I have to double check this. And then you see here that we have certain persons and they all have an ORCID. That's good. So you see interactively, you can pull your queries, you can even run them, and you can also actually copy the query result immediately from here, which is also JSON. So this is something you can do. Of course, that's not very efficient. Typically, you want to do this program something, and that's what we're gonna do next. So we go back to our notebooks. Yeah, so here we are. Again, we have to authenticate ourselves. And the first thing we're going to do is we're actually not searching the knowledge graph, so the public knowledge graph, we're going to search our space, which is the collab space that we previously used to create our persons. And because in that space, we actually didn't release any person, right? We didn't make that public. So what we have to do is we have to switch to the stage in progress. So this is what I do here, and if you execute that one, I'm not sure where my thing is. Also my okay. Yeah, so we have a person. So this is something I didn't expect because I expected that we did all the family given name thing. So we have one person in that list in our thing, which actually does not have either a family name nor a given name. That's why this is a breakdown. Let's skip over this. But what you can do is basically we would have now taken all the instances of our collab that are person and just print out all the given and family names for those persons, right? That would have been the output. This only works if the thing is clean, right? If it's not clean, then the program has to be a bit more elaborate to account for that, and this is not what I expected. I should have expected that, sorry. So I will fix this maybe later, and then you can have a look at this again. Then we're just going to continue with the next one. So this one is now a bit of safer because we're now in the released state of the knowledge graph, and we will actually run a query that I designed beforehand. I shared that query with you, so you should all have access to that one. This has a specific ID and it's stored in the collab space of our repository. And this query is going to follow. So it will go through all the datasets version in the knowledge graph that are released, right? So that part, so we don't have to define release because that's the default. We also do not define the space because actually things that are released can only be in the official space of the knowledge graph part. And the other thing you need to know is query results, especially here in the query builder, you saw the limit was 20. You can increase that one in the query builder. In the KG4 Python part, it's limited to 50. You can also increase that. I put in some information about here how you can do this. And you can actually also go iteratively through results. If you have a log, for example, if you're searching for files, there are like over 600,000 files now in the system. You don't want to load them all at once, right? You want to load maybe 10 of them or maybe 50 of them, and then the other 50 and the other 50 and so on. And you can do this with this. So let us execute that cell. And then when it's done, it should tell you, hi. So we have a total of 23 data set versions that were found and tagged with histology and contain a PNG file, and that was my query requirements that I designed for that query. And now we will print out the summary of all the files that are for these data sets that is found, and it will print out the full name, the DOI, the actual all the experimental approaches, not only the histology one, and it will print us the IRI of the PNG files. And you see here, we have the full name, we have the DOI, we have the experimental approach, and then a couple of PNG files. This brings me to another thing which I didn't point out in our preparation data and metadata. Do you see what is wrong with these files? Yes. So they use spaces in the file name, which will break every IRI because they cannot handle that. So if you design file names, never use spaces. Another thing which you should be aware of is some systems do not take care of capitalization, some others do. That's also something you should be aware of. And of course, all special characters like very, very special characters should be used with care in file names. But yeah, so this is, you see, yeah, doesn't matter. We go back to this one a bit. So either you copy one of the PNG files out here now that you want to like to have a look at. We're going to use this in the download part now as well. The interactive download, how you download data in the search, I already showed you. This is why we immediately switch now to the notebook of the download part. Okay, so we're in the downloading notebook. The downloading again works purely on the data proxy. So we're not doing this now with the node thing, but again, with requests, with the package that navigates HTTP protocols. We again will just use now first our own bucket that we have assigned to our folder. So we have a window. We have the bucket name again defined. We define again the bucket as we did for the data file. And now we define the file name, and I just took a file that I uploaded in the beginning of this workshop. And then we're going to authenticate ourselves. Again, if you do it locally, replace it with your authentication token, and you can always get that one either in the editor or actually also, just so you know, in the query builder, right? So here's also the copy token to the board part. So let's run this out. And then that was a quick one. Yeah, it should be quick because it's only one file. And then just to prove that we actually did download something into the notebook is that you see now here the file that we downloaded. And that's a little cartoon I made for my PhD thesis actually, which was also about data sharing, surprise, surprise, and that you actually share it with yourself, with your colleagues, with maybe collaborators that are sitting in different countries, so you can only speak with them over the phone. And of course, finally, if you publish it, you share your stuff with the world, so you have to do the part. Next, we of course want to download stuff from the release part of the knowledge graph, and this is what we're doing now. We combine this with the search we did before, so we're just going to copy one of the PNGs. I'm just going to take that one now. Feel free to choose whatever you like. I'm just going to copy that over. Typically, you would combine this directly in one code, right? So you don't have to copy stuff. So we run that cell, and I just enter here the PNG, and then you see, oh, it's already going on. I can't bother there. So this is a very, very simple example of how you can download code. If you want to do this more elaborately, of course, feel free to extend your code even with nicer code parts. So I'm really not a super advanced Python programmer. So I do the basic. I don't do more. But this is how you download data. As a reminder again, the same thing works also with the HTTP data, so with the data that are sensible and protected under this control access. If you do this code with these kind of data, what happens is that you receive the same email, right, that I received before when I did this manually. You will receive it, you click on the link, and then you can run your code again, and it will give you access to the data. For a certain time limit, right? So these links are typically, I think, you have 24 hours, I think, to download data from that, and then they will expire, and then you have to do the request again. Okay, so this is all I have for today, actually, because we now did this part already, and that one we just did. So we're now at the end. So I'm happy to take any questions, any feedback you want to have, right? And you want to publish through EBRAINS. This typically goes through, it always goes through EBRAINS. And there are certain formalities currently running for that one. So what you would do is you would first hand in a request that you want to submit data. And that request is evaluated, and then typically it's going through, and then somebody is getting in touch with you saying, okay, now you can go through the curation process. The first thing that happens is that we have to provide some metadata, and we are currently rethinking the whole, how should that be asked for, like how should metadata be provided, should people provide something in addition always, or should that be something that comes with the data first, and so on. So the process here is a bit flexible. Feel free to always provide feedback on the current process, which is a bit tedious, to be honest. So some of the people that share data, so Kai, for example, can share some experience on that also here at the front. And we have a couple of people. It's a bit tedious at the moment. Bear with us. It's improving, but it's also only improving with feedback. The other thing then is the collab, right? So upload, download through the bucket of your data. That's exactly what we did today. So the curation team will create for you a data set collab, which is only for your data that you want to submit. And then you can upload the data there either via the API, so either via programmatic part or just by drag and drop in the new one. And that really depends on the size of the data, I would say, right? And what you want to change on a frequent basis. Then the curation team creates these metadata instances typically for you. If you're interested in testing the editor and providing the metadata for yourself, always feel free to ask to do that. And we're going to add you an editor space as well, so that you can upload those metadata yourself and also maintain them then during the curation process. For this one, I'm always happy because, of course, you have to handle much more schemas and much more information. We're always happy to set up a special training session for that one. The other one is then if you're running through this process and you are working actually with human data or actually also any animal data, you have to do an ethics survey. That's just because we are a European infrastructure and Europe has certain rules on animal studies as well as human studies. So you have to do this ethics evaluation. For human studies, this means that you have to also provide, if you're working on living humans, that is, you have to provide that you actually did informed consent with the people in order to work or share the data. And the ethics generally just checks, like, what did you do an ethics application, which you took typically for your data if you're working with animals, and then just making sure that you follow European regulations. For all of you that are sitting here, this is not going to be an issue because if you're studying something, you're going to work with European regulations anyway. For people in Canada, this is also typically not an issue because I think the regulations match very closely. For people working in China, this is a bit difficult sometimes. So there it really has to be checked if European regulations are followed because they are different animals' rights over there, and they sometimes collide with the European rules. So that's just something that needs to be double checked, and we have an ethics team doing this. And then the curation is just more or less a bit of an interactive process, and it depends a bit on how well you get your data. So if you come with data sets that are enriched with a lot of metadata already, that has a nice description, for example, a nice data descriptor already attached, then this will be a very quick process. If you don't come with the data descriptor already prepared somehow, then you have to write it from scratch, which is always a bit of work, and the curation team typically gives feedback on this one as well. So then it takes a bit longer, and of course the curation team also has to work with this because extracting metadata from a written text instead of something that is accompanying the data is always a bit more difficult. But yeah, so this is a bit of the process that runs behind it, which of course has then in the end the reward in sense of you get a citable UI for your data sets. In case you only want to register metadata for data that you publish elsewhere, right? So there's also other options, right, out there besides EBRAINS. You can also just register the metadata in order to highlight your data also in the knowledge graph, and then we will actually point to wherever you publish. So there is also, for example, a very nice data server called JIN from the German node of the neuroscience coordination facility. Canada, of course, has their own servers and publication options. One big one, most of the imaging people know is open neural, right? So a lot of people publish on open neural. A lot of people publish on neural models. And then there is the Zenodo and of course Figshare. Problem with all the non-European based ones is that they don't follow general data protection regulations. So actually no one in Germany or other European countries should be able to publish neuroimaging data on open neural because there everything is open access. Scientifically speaking, or open scientifically speaking, this is super nice. Data protection regulation makes this actually impossible to legally do that in Europe, which is a bit of a tricky part because there are also gray zones and so on. So it's a bit of a thing. But yeah, I'm not an expert on this. I'm involved in several of these issues, but we have a whole data protection group, and of course, EBRAINS and HPP have data protection officers who take care of these legal issues with these data. Yeah. Otherwise, of course, if you also have software, right? So we also share software, so register software. If you're interested in getting involved in any of this actively in the development of the tools, giving feedback in development of open minds, then feel free to get in touch. We are always happy to get other people involved, but from outside of EBRAINS. So the official way of doing this would be, I'm just gonna show this to you. So I put in here a couple of things, right? Generally for EBRAINS. And under curation, you see on the one hand, there is the curation support EBRAINS email. That's an email you can always write to if you have questions or requests or want to set up a meeting for the curation of a larger project. If you do this and you want to talk to me specifically, then you should ask for this in the email directly, because otherwise it will be just propagated amongst our curation team. We have a homepage which actually holds all of these information as well. And then we have the official way of request, right? So you always would start with a request for sharing data. And this is really now for one data set. So I'm just going to go through this. So this is just a thing we have to do for data protection. And then I'm going to say, well, yeah, I'm doing this. I'm going to provide some information on myself here. And then I pull this out. I'm not going to go through this now. It will ask me for what I request the curation. So, for example, if I do experimental studies, simulations, computational models, and software, just because we have different experts for curating those, and that's helping us to navigate this a bit. And then I typically also say what I am, right? So, am I the custodian and the contact person? So for now, I'm just going to say yes, yes, yes. And I'm also gonna here actually gonna say no. And yeah, of course. What did I miss? Yeah. I hope that's the only yeah, I don't want to go through all of this now. But this will ask you certain things, right? So about yourself, about the data set you want to submit. It takes typically 5 minutes to fill that out, and then we get the request, and then you are contacted once this is through. And then either a personal meeting can be set up, or everything can be handled via email. That depends a bit on the complexity of your data set and how much you want to do yourself or learn yourself in that context. For specifically now EBRAINS, right? For everything that comes from your side, I would suggest we should not go through that process. We should actually start with like collaboration, so that you don't have to fill that out for each single data set that you come in with, for example. Yeah. Which I have to just announce to curation so that it's clear that these data are handled differently. That's true for all of them, right? So if you are working in a larger collaboration and you want to produce data sets on a regular basis that are going to be shared through EBRAINS, it's always worth talking to us to set up maybe something that navigates you a bit around the normal format, like all these formal things that we typically do with one-time data provider sharers. So this is something we can do. We do this, for example, for the ULIS team as well, right? So not all the things that are published through the ULIS brain go through every single one of these aspects. Yeah. So thanks a lot.